So the social psychologist Abraham Maslow once wrote that if the only tool you have is a hammer, you tend to treat everything as if it were a nail. So in order to understand and resolve conflicts, we need to have as many different tools as possible, like screwdrivers and pliers. So one of the tools that's proved very successful in the physical sciences is the use of mathematics. So how can mathematics help us understand the complexities of people and their emotions and their feelings and their history? Well, one of the advantages of mathematics is that it forces you to make your assumptions very clear, because you're going to have to turn those into the equations that he was trying to frighten you with. And then solving those equations, we can sometimes find the unanticipated consequences of the assumptions that we've made. And in fact, sometimes very simple equations like Newton here in his law of gravity can have very far-reaching consequences. So this very simple equation explains the motion of the planets across the sky, the shape of the Earth. It's a little fatter around the equator, and tides in the ocean. So what we've been doing is to see what sort of very simple model, or the simplest model we can make of a conflict. So we start with a model with only two people, and we look, the variables are their emotional state, how happy or unhappy they are. And we say that the current emotional state of each person depends on how that person feels when they're alone, how each person was feeling a little while ago, and how each person responds to the other person. So for example, let's say we have an employee that goes into their boss for an annual evaluation, and they're also hoping for an increase in their salary too. Well, there's two ways they can interact with each other. They can be on the same wavelength. Maybe they're really friends, or they come from the same cultural group. So if one of them is happy, the other one is going to be happy. On the other hand, perhaps just the opposite happens. That this employee and boss have not been getting along. Perhaps they know they have very different political opinions. So whatever makes the boss happy, it's going to make the employee unhappy, and vice versa. So what we do is we put these equations into a computer from these very simple assumptions shown on this graph, where the vertical axis is the emotional state of each person, where up is happy and down is unhappy, and we compute on the horizontal axis what happens in time. In this case, both of them wind up being happy, which seems reasonable. But if they're doing the opposite of each other, in this case, the boss starts off being a little happier, and the boss winds up being happy, which makes the employee unhappy, and vice versa. This is also pretty obvious. But now the mathematics tells us something that we weren't expecting. It shows that if both of them start off feeling sort of emotionally the same, they'll first wind up being neutral, but then they'll separate. So one of them, in this case, the boss, will be happy and the employee unhappy. If you just saw this from the outside, you would think some very important external event happened here. No external, for example, maybe the boss got a phone call saying the company is in economic trouble and they're going to have to fire someone. Maybe the employee overheard part of that conversation. Nothing like that or anything else happened here. The mathematics tells us from these very few simple assumptions that this sort of behavior is actually what will happen. Another example is shown here, where one person is trying to do the opposite and the other emotionally the same. And this push-pull results first in oscillations, and then later they both wind up being neutral. Without the mathematics here, I wouldn't have been able to guess they both wind up being neutral. So what we've seen from these computer simulations and quite a number of other ones is that it used to be thought of, or is still thought of in the conflict resolution literature, that we want to get one person to do the right thing. and then maybe the other person will change their strategy to do the right thing. What we're seeing here is that if one person changes their strategy, the dynamics of both of them change, even if the second person is not changing their strategy, because their dynamics depends on what both of them are doing. Well, the world consists of a lot more than two people. So we've been making models of many people interacting in what's called a small world network. So the people here are represented by red dots, and there are links to other people by these black lines. So locally, that would mean people in their neighborhood where they live, and maybe in the office where they work. But people also have long distance connections to people in other cities or other companies. And what we've been studying is what happens if most of these people are trying to do the opposite of each other emotionally, or what happens if they're doing the same, or what happens if there's a mix of different strategies or behaviors. And what we found, perhaps surprisingly, is that this network of many people functions best, meaning it's not too fixed in time and not too random or chaotic in time, and that most people have the similar range of emotions when there's actually a very good mix of behaviors, and when people have roughly about half doing the same emotional thing as each other and half about the opposite. And this network actually functions better than if everyone was trying to do the same as everyone else. So what we found from these computer simulations is actually that diversity is best for the whole network of how people are interacting with each other. So Goethe here basically said that leaves are green and all theories are gray, and that's certainly true. And we're never going to have a mathematical model that's going to explain all the wonderful and terrible aspects of human behavior. But the mathematics gives us another tool to add to our toolbox that can help us in some ways understand conflicts, maybe anticipate the directions they're going to go, and may be able to help us think through new ways to resolve conflicts. Thank you.